Speaking, I'm not Yoruba. If you want us to learn 217 practice. You said it's generally lock your mood. Because I saved this link before. That one back system. Yeah, I saved it. That's why I could easily. About 657 participants already. Don't worry, when they start, I'll give you one of the
guys should stop making. Are you bad?
I'll tell you who you are behaving like. Very soon. But not now. You look like somebody that really people. Joe. Mi mú kó pè láyé mi. Àbí fẹ́ sí. Ìdílé fún láyé jẹ lónìí. Ìjẹ́.
Hello. No, never. Hello. Hello. Okay. Thank you. So today, we are just going to do some revision or tutorial, have some tutorial class. We have finished, excuse me, please. They have started again. Something I'm supposed to do. Okay, good evening all. We have finished the aspect of kinetic molecular kinetic theory of gases. And so it's sort of, what we're about to do now is kind of tutorial. Stop it. Now. It's a kind of tutorial at least to help us understand a bit what we are likely to see in the exam or test paper. So I'll just type some questions and we solve them. And then if you have any question, you can ask. I will unmute those who raise their hands when I'm through with this tutorial, okay? So the first question is, calculate the ratio of the diffusion rate for water, that is H2O and D2O. Deuterium, we know, is an isotope of hydrogen. So I will just write it here. This should be H2O subscript 2O and D2O subscript 2O. Now, if we are given that calculate the ratio of the diffusion rate for water and deuterium oxide. Now, the molar mass of water is 18, given that the molar mass of water is 18.0 gram, 0.1 gram per mole. Gram per mole. And that of deuterium oxide is, that of deuterium oxide is 19.0 gram per mole. So what aspect of the gas law is this? What aspect of the gas law is this? You can type under chat. What aspect of gas law is this? To solve this question, what aspect of gas law are we dealing with here? Alasade Oluwaseun. You raised your hand. I have unmuted you. What is the question?
person was not listening.
Hello, can you hear me? Hello, Alashade Oluwaseun.
Yes, I hear you.
You can hear me? Can you hear me?
Yes.
So the question I put on that, your place is noisy. What is the problem? What I put on the board, what aspect of gas law is that?
Yes.
Wait, you are noisy.
It's Graham's law of diffusion.
Graham's law of diffusion. Thank you. Okay, he's right. It's Graham's law of diffusion. So what do? Rates. We say the rates of solution. Solution. So we say rate of diffusion. Now, which gas is heavier? You have to know the one that is heavier. Which of the gas is heavier? Well, which of the molecule is heavier? So it will be rate of diffusion of water, diffusion of water over rate of diffusion of deuterium, D2O, equals equals MD. Please, this is okay. MD2O over MH2O MH2O MH2O, so root of that. So rate of this, we said the ratio of the rate of diffusion of this. So we were not given the rate of diffusion of either of them, but the ratio is what they want. And what is the ratio? The ratio is what? Root of molar mass of deuterium oxide all over molar mass of water, which is equal to root of 19 19.01 gram per mole all over 18.01 gram per mole. Gram per mole, so root of that. And so if you work out this, what is the answer? If you work out this, what is the answer? Okay. Oludele John. Oludele John. What is the answer? Oludele John, what is the answer? I've unmuted you. Answer the question. Okay.
Ma, the answer is 1.027, ma.
1.027.
027, yes, ma.
Okay, that's good. That one, 1.027. That is the answer. Correct. Are you sure? Let someone else use his calculator. Let's see. The zero, after the decimal. I want to see if there's another option. Does someone have something different? You said 1.027. I want to be sure. I want to be sure if your this thing is correct. Let me see. Isaac Olufumbi. Oh, Fokumbi. Isaac Fokumbi.
Ma is Isaac Olufokumbi.
Olufokumbi, okay.
Yes, ma. Yes,
Do you have
Isaac.
what is your own answer?
I got 1.0271. Same thing.
1.0271.
Yes,
okay.
ma'am. So, ma, a question, is it 19.01? Because you gave us 19.0 gram per mole, but you wrote 19.01 gram per
Sorry,
mole.
it's 19.01 gram per mole.
Okay, no problem.
Oh, okay. Maybe that's what is affecting.
1.027. It's the same answer I got, ma.
It's the same answer. Okay. That's correct. Okay. Thank you. Okay, so a second question now. You can write down for practice. Two gases. Let me type again. Two gases
Did you later put it back inside this thing? Look, if I slap you one day, you know you don't play with pieces of chess. I will know. I will know, sir. 132. 32. Wait, oh, but when you just count the white one, if you are 2.
Question 2. Two gases.
7, 8, 9, 10, 15, 12, 13.
Hydrogen bromide and methane. Two gases, hydrogen bromide and methane. CH4. Please, the 4 is subscript. The 4 is subscript. Let me see. Two gases, HBr and CH4, are fused through a small opening. A fuse through a small opening. A fuse through a small opening comma. Now HBr, hydrogen bromide, fuses through the opening at a rate of through the opening at a rate of 4 centimeter cube per second. At a rate of 4 centimeter cube per second. Four centimeter cube per second. At what rate will the methane molecule or methane gas, at what rate will the methane gas, that's the CH4 gas, at what rate will the methane gas effuse through the same opening? Effuse through the same opening. Effuse through the same opening. Effuse through the same opening. So solve and give me the answer. So you try your hands on this and let's see the answer. And question 3. Question 3. Deborah, you were raising your hand. Do you have a question? Deborah.
Regarding the, yes.
Okay, ask your question. Yes, I can.
Yes, it is regarding the our chemistry 150 is on our LMS portal. We can't find it again on our dashboard.
Are you serious? What happened? So,
yes,
but are you in this class? Are you in this class?
Yes, ma'am. Yes, ma'am.
So how did you get to the class?
It was through the link. They sent a link to us in my department group. They used to send a link to us every morning. So I get to the class through the link.
Wow. You are not a chemistry major student.
I'm not a chemistry major.
So what happened?
We don't know.
Do you have your class rep? Is it general for everybody or is just for you?
And most people are also complaining it on the chats. So I thought it was something personal before, but I discovered that most of the students are also complaining.
Okay, so who represents you people in terms of speaking with management?
Is our class rep.
Now, so let your class rep do something about it. Although I'll try to find out what is happening.
All right, ma'am. Yes, ma'am.
Abdul Muiz, do you have a question before we continue? So please, if I have answered your question or I've asked you a question, those who raised their hand, are you still having questions? Or those I've talked with? If I have finished with you, please put down your hand so I know those who want to ask questions before we continue. Abdul Muiz, Abdul Latif, Abdul Muiz, Abdul Latif. I think are you unmuted? Yes. Any question?
Good evening, ma'am.
Good evening.
I have a question, ma'am.
Okay.
So the gas that is heavier.
The what? The gas that is heavier. Okay. It's with the molar mass, you know the gas that
Yes,
is
sir.
heavier.
Yes.
Yeah.
The one with more molar mass, right?
Yes, it's always the heaviest.
Thank you, ma'am.
You're welcome. So please put down your hand. Oladokun Oyindamola. Oladokun Oyindamola. Oladokun Oyindamola. Why? You have refused to unmute. Okay, let's try another person.
This is from Google.
Faith.
Good evening, ma'am.
Good evening, Faith.
Yes, ma. The question 2 that you gave us,
Yeah.
you didn't give us the molar mass of bromine.
Okay, but you know the molar mass of methane.
Yes, ma'am.
Okay, so for bromine, take 159 gram per mole.
All right, ma'am.
159 gram per mole. 159 gram per mole. Okay.
All right, ma'am. Thank you, ma'am.
You're welcome. Oyindamola Oludele John. Yeah.
Ma, I have a lot of questions, ma. The
A
first
lot.
question is-
No,
yes,
it's
yes.
two. So the others
Just
can
two,
have
okay.
chance to ask.
Okay, I'll make it, ma. I'll make it.
All right. All right.
Yeah, the first one is back. The very first question you gave us, the one I answered. that I answered. Yeah, you said the molar mass of deuterium oxide is 19.
19.01. Sorry.
19.01. Yes.
Yes.
And I don't know, but deuterium, the mass of deuterium is supposed to be 2. So if I calculate 2, it's supposed to be 20 gram per mole now. I'm somehow confused why it is 19 instead of 20.
It is what I give you, you use. You make do with what I give you. Yes.
Okay.
It's what you see there, you use. Don't use your own. Except you are not given and you have calculated it. But otherwise, like water now, so most times we use 18 grams, but I've decided to make it 18.01. Do you understand? So it's what you see, you use.
So thank you very much, man.
You're
The
welcome.
second one is that
Who are those? Who
you
are
said,
those making noise there in your end? Please ask them to reduce the noise.
I'm
Or you
sorry.
move
I'm sorry
away
for the
from
noise, man. The second question is that for the chemistry 156 class that the other girl complained of, I
Yes.
think she should go back and re-enroll. It's a general problem, so I just
Okay.
went, I checked, and I re-enrolled myself for the course. So it's
Okay.
general.
Okay.
All of us are facing the same issue.
Thank you very much
Yeah,
for
thank you very much
helping me.
Thank you very much for giving me the opportunity to speak. Now I'm very grateful.
No, yeah, welcome.
Thank you.
Yeah, welcome. Bolaji Oreoluwa. Bolaji Oreoluwa. Oreoluwa. Yeah, okay.
Ma, please, I wanted to ask that the slides are not available on the Moodle app, ma.
Which slide again?
The slides for the classes that we'll be having.
Thank you very much. I'll send it. Thank you. I'll send it.
You.
Yes, before Friday, I'll send. If I don't send it after the class, I'll send it maybe before the day runs out. Sorry about that.
Yes, ma'am.
Jennifer. Yes, Jennifer.
Good evening, ma.
Good evening.
Ma, please, my question is that would we be giving the molar mass in exam or test, or we have to have for knowledge of it?
You will be given.
Then, ma, in combination with the slides that she said, would the YouTube videos be made available?
That's what I don't know.
Okay,
I'll find out.
Then, ma, when you were explaining, you said rate of the, I think you said rate of the smaller one over rate of bigger one equals to square root of molar mass of, I want to confirm, is it rate of the smaller one or rate of the bigger one over rate of the smaller one?
Rate of the smaller one over rate of the bigger one.
But ma, you put deuterium has a higher molar mass, 19.01, but you put it over hydrogen, 19.01.
What you do is when you go back to the original, what is it? The original formula.
Yes, ma'am.
Trying to work it out. You see, it is over the molar mass. Molar mass is rate of the smaller over rate of the bigger, square root of the bigger molar mass. Check and find out. There's nothing.
Okay,
that's what it should be. Yes.
Then, ma, my last question is that, ma, what about our test?
When we get to that bridge, we will cross it. So just be reading, because by Monday, the next person has to take over. We are rushing to finish, yes.
Okay, ma. Thank you very much, ma.
You're welcome. Please, if I've spoken with you, put down your hand so I know those I have not given a chance to speak. Oluwamayowa. Oluwamayowa. Okay, Oluwamayowa. See it. Oluwamayo.
I'm sorry, ma'am. My question has been answered.
Okay, I can hear you. What's your question?
My question has been answered already.
Okay, please put down your hand if it has been answered. Please, if your question has been asked and answered, put down your hand.
No, you don't die.
Where is it? Please mute yourself. Akinlabi Abdulaziz. Akinlabi Abdulaziz. Okay.
Please, my question is this, ma. You said earlier that the higher the density, the higher the lower the rate of diversion.
Yes. Is it the higher the density? Yes, definitely. Because it's weight.
Now, my question is now that when we were doing deuterium.
Wait, ask the question again.
Yes.
The higher the
density.
Okay.
The lower the rate of diversion.
Okay.
Now, I said during the time we are solving that of deuterium, you said the molar mass of deuterium oxide, that's D2O, was 19.01. Now, and I want to ask that, can we know the molar mass of deuterium on its own?
Deuterium is 2 now. It's supposed to be 2.
Deuterium should be 2.
It should be 2, but I have given you.
Okay.
I've taken it as 1 point something.
Thank you very much. That's what I want to ask, ma. So if
it doesn't, it's what I give you, you use.
Thank you very much. That's
whatever I give you, you use. Okay.
But if you are not given, then we use the standard one.
Yes, use the standard one.
Thank you very much, man. You're welcome, man.
Yeah, welcome.
Okay.
Ayola Blessing. Ayola Blessing, you are on.
Good evening, ma. Can you hear me, ma?
Good evening. Yes, I can.
Ma, my own question is about the class we did last week. I wanted to ask, but I was not called.
Oh, sorry.
Ma, when you gave us an example on the root mean square.
Square velocity, okay.
Square, yes, ma, of ammonia molecule at 22 degrees Celsius. And you converted the molar mass of ammonia from gram per mole to kilogram per mole.
Yeah.
Then in your slide, one of those questions you wrote there, you said we should calculate the root mean square velocity of chlorine gas. But you did not convert the molar mass of chlorine gas, and it was the same parameters that was
Did I solve it?
Yes, ma, it was solved in the slide.
On the slide, the slide I gave to you.
Yes, ma.
Are you sure I gave it to you?
Yes, ma, I saw it there.
I gave it to you, or the one you purchased?
I did not buy any slide though.
I heard they were selling slides to you. So.
No, me, I'm at home, so I did not buy any slide.
Okay, that's good. Well, maybe it's a mistake. Please rework it out. Maybe it was an oversight. Sorry about that.
Okay. Thank you, ma'am.
You're welcome. Thank you for that observation. Okay. Abraham Fatumbi. Abraham Fatumbi. Abraham.
Hello, ma.
How are you?
Good evening, ma.
Good evening.
I'm fine, ma. Please, I want to ask concerning bromine.
Yeah.
What do you call the molar mass? Is it the bromine only or hydrogen bromide?
Hydrogen bromide. No, sorry. It's bromine.
What's the molar mass?
Oh, it's bromine. Bromine, the molar mass of bromine, 159. The molar mass of hydrogen, take 1 gram per mole. So that would be 160.
Bromine,
bromine is
160. Okay, ma.
159.
Thank you.
Yeah. So with hydrogen, it will be 160,
Okay.
please. 160.
All right. Thank you, ma.
Please, others, take correction, please. Okay. Ozilibo, blessing. Ozilibo, blessing.
Good evening. Ma.
Good evening. How are you?
Good evening, ma.
Good evening.
Okay, ma. Okay. What of the subtopics under kinetic theory of gases are we to read it on our own? Because you said by Monday another person will be teaching us another topic.
Yes. Which other subtopic? Which
Oh,
subtopic?
I actually went through.
Okay. Read everything you can read.
Ma, do you recommend the textbook for us?
Did I recommend a textbook? Some were recommended.
Okay, can we read outside the scope of what we were taught?
Why
outside
not?
the scope.
Why not? It's for your good.
How about good? Okay, ma. Thank you, ma.
For more knowledge, you can do that.
Oh no, like for the benefits of exam.
The exam.
Yes.
I don't know, but read as much as you can. It's okay.
Oh, okay. So, thank you, ma.
You're welcome.
Everybody knows.
Adekoya Kende.
Hello, ma.
Yes.
Hello, ma.
Who is talking?
Adekola Kende, ma.
Good. Okay.
Yes, ma. Ma, I want to ask that concept because I checked my LMS and I could not find the slide for this kinetic theory of matter.
You've not found any slide at all.
Yes,
I've sent a part of the slide. A part of it I've sent.
Okay, I will recheck it, ma.
After the last class, last week I sent something. So it's just the one we've had this week that I've not sent. Was it last week or this week? I think on Monday or so, wasn't it? I've sent something. I've sent a part of the class. So the remaining part I will send. Maybe I will send everything again.
Okay, ma. Thank you, ma.
Okay, you're welcome. Bankole Rufus, Michael.
Hello, ma. Good evening, ma.
Good evening. How are you? Hello? Hello?
Hello, ma. Can you hear me, ma?
Yes, I can. The thing's on. It's meeting. Hello?
Hello, ma.
Okay, I can hear you.
Yes. My first question is from the practice question you gave us the last class, ma.
All right.
Yes, under the question that deals with the root mean square velocity. So the options that were in the practice question, I don't know, maybe it's me. I'm not getting it with the use of that square root.
Root means square velocity?
Yes, ma.
Did I give you answers?
Yes, there were options in the something. There were options there.
And you are not getting it?
Yes, we do. I make use of the square root, the normal formula, but I'm not getting it. There are bigger values there in the option. And when we make use of square roots, we always have smaller values. So I'm somehow confused.
Are you sure you are doing the right thing?
Yes, ma, the right formula.
Did you change the molar mass to kilogram per?
Kilogram per.
Did you?
Oh, that's true. Then I will check again. Then, man, the second question, ma.
Okay.
Yeah, concern the vibrational degree of freedom.
Freedom. Okay. Okay.
Yes, under the CV formula, you said sometimes the 3/2 will not be given, that it will be I/2R.
Yes.
Then you have to calculate the vibrational degree ourselves.
You have to
So,
calculate you have to calculate if I over 2 is what you are given,
yes,
that means you were not given the degree of freedom. You were not given I. That means from the molecule, you have to calculate I yourself.
Okay, ma'am.
And that will be, I think, when we talk of degree of freedom, the I you are using is the translational and rotational motion, I think.
Okay, that's what I want to ask. Translational.
And rotational
Thank you very much.
motion. You're welcome. Okay, the last person before I end the class. David Ikechukwu. David Ikechukwu. David Ikechukwu.
Yes, ma'am. Good evening, ma'am.
Good evening.
Okay, you said that to solve the rates, we must put the one with the smaller mass up, then one with the lower mass down. Ma?
You said must. It's not a must, it's what you like you do. What is the original formula given to you?
The R1 over R2 equals root of M2 over M1.
R1 over R2 equals root
of
of
M2 over
M2.
M1.
Okay. That's it now.
Ma?
That's it now.
So what I'm saying is that, but if we solve it either ways, as in putting the molecules, as in putting the compound with the bigger mass up, and that with smaller mass down, we can still get the same answer.
Are you sure?
Yes.
Are you
because
very
when you have yes, when you have R1 over R2 equals root of M2 over M1, it's still the same thing as R2 over R1 equals root of M1 over M2.
Okay,
When
all I
solve
need
it
is my
mathematically.
answer. It's left to you. Okay. So there's no problem. As long as you get my answer, no, I don't want to know. You're not going to show me how you worked it out. Okay?
Okay, ma'am. All right, ma'am.
Okay, have a nice evening. Henry Oyoyo. Henry Oyoyo. Oyoyo. Which one? Oyoyo. Henry Oyoyo. It's not there.
Hello, good evening, ma'am.
Good evening.
My questions have been answered along the way. So
No, you should have put down your hand so that we don't waste time.
no problem, ma'am. I'll do that right away.
Okay. All right. Okay. So I think at this juncture, we'll call it a day. And I wish you all the best. Just prepare for the exam. With this slide, I'll add more questions, more tutorial questions, so you can practice enough before the test and the exam. So God bless you. Do have a great evening.